Perfect. Alrighty. Oh, hey, we've got some folks from over the border. We've got Connecticut. Oh no, everyone's saying hello at once. Winnipeg, Victoria, Bridal Falls, Mara, BC, sunny Toronto, Texas. Thank you all so much for joining today. Today is a particularly special day, I suppose, for those who don't know yet. This is unfortunately going to be the last episode of Insider's Guide to the Galaxy. It's been quite a ride, eh, Chris?
Yeah, it's been quite the ride. I like to say mission accomplished because way back I was just looking at the emails, resurrecting the old correspondence between Jen and I. When lockdown started in March of 2020, it just came into my head that what can we do to keep people engaged and interested in astronomy and inform them, and what are all those parents going to do with all those kids sitting at home from school? Maybe we can run a live astronomy program in the afternoons, and we picked 3:30 p.m. thinking that was a time before dinner time. Let parents get their dinner ready and things like that, and engage the kids. Little did I know that it would have broad appeal to all ages, that it wasn't going to just be kids. And when we sort of, the first few topics and ideas we threw around were kind of, we did a scavenger hunt. We thought that would be keeping kids busy, get them. We taught them how to use Stellarium, and then we gave them things to use Stellarium to look up and do things like that. And then we ran, yeah, we did two a week for the first little bit.
First. Yeah, that
so
was
sort of question and then that answer day. And we didn't have anything else to do, so that was fine. But we eventually settled down on our twice a month pattern and went from there. But yeah, that's from March of 2022. I see you did you tally up the numbers, or did you guesstimate how many we've done?
Oh, we've done 76 episodes total. I'm
Amazing.
not sure though that that's necessarily counting. There was a period where I was away and there was finest NGCs or Messier minutes or something going on either side. I'm not sure if they count, but if they don't count, then we have 76 episodes.
Great. Yeah.
Which I think is pretty good.
I sat down a few months ago, I guess it was, and I wrote down a list of all the topics and the dates that we'd done. And it's impressive to think back. Not only the number of topics we've covered, but also the number of guests we've had on, the variety of things we've done, from Indigenous to women in astronomy, all kinds of things. We managed to make it really, really broad in what we covered. So happy to have done that.
And it's all, I want to highlight for everybody here, sort of a little bit of what goes on in the background. Chris does almost everything for this show. Chris prepares notes and he comes up with the topics and he comes up with a lot of the information. And at the time when I was around, I only supported on the technical stuff. And as like the person who didn't know that much about astronomy at the time, now I know a lot thanks to all of our time together, Chris. And then Samantha took over, and then we had Charles on as well. So Chris has been a champion volunteer, and there's unfortunately only so much support that we were able to provide over the years. We are currently in a spot right now where we're pretty busy in national office, and we've also we're like lower in our staff numbers as well, so it's harder to support as well. So I know there are a number of people who are asking for us to like drop back the frequency, and why is it ending? It's Chris has other stuff in his life.
Yeah, I can address that. First of all, Janet, thank you so much for the warm words in your announcement. I mean, that was amazing and unrequested, so that's fantastic. Basically, like many other people who kind of sat on the couch for a couple of years during COVID, my professional business had to do with writing astronomy and things like that, which kind of kept going. But I also work a lot with people that produce the inflatable planetariums. And, I go do demonstrations and I train their customers and I visit trade shows. And that has all come roaring back after COVID in the last year and a half or so. So I'm just finding I'm not having anywhere near the time I once had, to do all the research required. And I don't like to, do a half job. I like to do a thorough job. So it really does require putting in the time. So having said that, I think after 3 years and so many programs we've covered, there's only a couple of topics that I think we've missed. But what I said to Jenna in my, announcement is that I'm still around. I'm still here. I just don't want to be, on a regular schedule the way I've been. And that if there's a special topic or a special event that comes up and somebody wants me to put my 2 cents in, I'll be happy to jump on and do some of that. No problem.
Thank you, Chris. And we may very well host some reunion episodes or some throwback episodes, and maybe we'll cover those topics that we missed. And there's a possibility that we may host another series in the future. So we'll see. We're keeping our minds open. It's stopping for now, but not forever. And I also want to acknowledge some folks in the chat as well. One in particular, where'd you go? Wendy, you were saying both of us have been your BFFs during the pandemic lockdown. I assure you that having this during the pandemic lockdown helped both Chris and I get through it too. It was really,
Sure.
really nice to get everybody together and to meet so many new people as well. A lot of some very close friends of mine through Rask I've met through this show. So thank you all so much for coming and joining us every Tuesday at 3:30.
Absolutely. And Charles would have been here today. He unfortunately had another matter that he had to attend to at last minute, so he wasn't able to make it. But shout out to Charles, shout out to Samantha, of course, Jenna, and everyone else that's joined on. So that's been really good. Yeah. There's something else I was going to say, and I forget now. Just think a minute. Anyway, it'll come back to me.
So we don't have a ton of content today. Actually, we had a different Chris had a different show planned. Chris and Charles, I've just only been back here in bits and pieces. But Chris and Charles had a different show planned today. Unfortunately, just because of the way things work, I believe it was a scheduling conflict with York University.
Yeah, we were going to do a live show from the York University's Alan Carswell Observatory in association with Dr. Elena Hyde, who gave me a call this morning. Thanks, Elena. They were actually taking advantage of the summer downtime to do repairs in the observatory space, not to the telescope, but just kind of to the sort of older building that it's in and things like that. So she let me know, unfortunately, that she didn't think that the work would be done in time to host us. The first time we tried early in the month. And then she said to me that it might be ready in time at the end of August, but since we have this regular time slot, I needed a firm commitment. And so I said, okay, well, we'll try another time. And then she called me to say she thought they would be finished today, but perhaps not by 3:30. But we'll make something happen and showcase their great work sometime down the road. Either me or someone at Rask can visit. Then the other news that I can share is that I'm actually uprooting and moving my operations from northern Toronto up to Collingwood in the next little bit. So that's another, I won't be quite as local to Toronto as I once was.
But you'll have dark skies whenever you want them.
Darker, yeah.
Darker.
I still have a bit of drive to go to get out of the Collingwood light bubble, but it should be nice. Very nice.
It's very exciting news.
And the other note, so I see Jenna put a mention of exoplanets in her announcement. And the way this typically worked is that I'd sit down and kind of plan ahead, what kind of topics can we cover at any given time, given what's up in the sky at those times. And so I had looked ahead and thought, oh, well, in late summer, early autumn, we get Pegasus returning to the sky. And that would be a perfect time to talk about exoplanets because Pegasus hosts the very first exoplanet ever discovered by humans. And that's the star 51 Pegasi. And if you like, we can kind of take a look at that and show people where it is and talk a little bit about that story too. And then Jenna's got some background in how we detect and measure exoplanets, so she could share too.
Yeah, this one's going to be a fairly loosey-goosey episode.
Yeah, but do stay tuned because I am going to finish the finest NGC list at the end.
Yay. If anyone has questions as we go, please throw them in the chat and we're happy to answer them. There is one already for you, Chris, which is, are you going to still be involved at the David Dunlap Observatory?
I think so. What I do is I spend one afternoon a month with my portable planetarium at the DDO. And so I think what I'll try to do is make that into a full day, maybe some morning sessions and afternoon sessions to make it worth the drive down from Collingwood with the planetarium, once a month or so, weather permitting. I've also been busily helping the Toronto Centre, train the new generation of operators of the giant telescope. And I could put a plug in if you don't already know that the Toronto Centre is, has agreement with Richmond Hill to operate astronomy programs at the David Dunlap Observatory. And part of that is that if you're a Toronto Centre member and you've got the right stuff, you can be trained to operate the 74-inch telescope at DDO. So I have a couple of if I'm the Jedi, I've got some Padawans that have learned under me, and they're now sort of taking the lead there as well. So I got a legacy that I could kind of,
Chris was Chris was one of I was introduced to you, I think, Chris, maybe 3 weeks in to my time at RASC in my first job here. And I was very lucky because Chris was training some people to use that telescope. And we got to go inside of it, bearing in mind that the telescope mirror is 74 inches, you said?
Yeah, 1.88 meter diameter mirror.
74 inches tall. I am 65 inches tall. So we fit 4 people in there, which was so cool.
Yeah.
Best experience.
So yes, the answer is yes. I'll try my best to help keep things going at DDO the best I can, but from some of it will be from a distance.
Sounds good. Alrighty.
Yes.
I just sent, for anybody who's interested, I just sent the link to the playlist of Insider's Guide episodes in the chat. So if you'd like to take a look, they're all there. Okay.
Yeah, so somebody mentioned the Carr Observatory. That's the Toronto Centre's Carr Observatory, south of Thornbury. And yes, I will be about 25 minutes away from the Carr Observatory when I'm up there. So that's nice. That's nice to have that as well.
Mm-hmm. Have you mentioned the Carr Observatory on here before?
I don't know that I have. In fact, that's sort of, something that we might have done at some time.
Yeah.
Is to have a bit of a visit and a tour. And I guess that's still in the work, in on the table as a possibility now that I'll be up there if somebody's interested in doing that sometime.
For those who don't know, Toronto Centre owns their own observatory in Collingwood. And you can, in addition to your Toronto Centre membership, you can also add on a membership to the Carr Observatory.
That's right. So there's a 3-bedroom house, I believe, on the site, and it's been kind of divided up so that they can sleep a number of people. So you can, visit for the day, visit for the evening, or stay overnight, spend a weekend or a few days longer at the site. We have a 16-inch RC telescope on a Bisque Mighty MT mount, Mighty mount. Forget which one it is. So that's great, and a roll-off observatory roof, and then a lot of there are some SkyShed pods that various members have kind of rented space in, and so it's great. So it's quite the thing if you're in the area and you're a rascal and you want to visit, or know a rascal who can connect you, then you pay us a visit. Cool. So why don't I show everybody this exoplanet star, and then we can kind of take it from there. And Jenna, maybe you could talk a little bit about RASC's history around exoplanets too here in a second. So let me just share my screen. Do this. Cool. So for those that may not be aware, this is the sky this evening at about 9:30. And you can see the great square of Pegasus is rising, climbing the eastern sky at this time of the year in evening. And next time you're out and you're looking at Pegasus, it's kind of the baseball diamond shape. I think it's about 2 fist diameters across, and I think each side is about 1.5 fist or 16 degrees or so on a side. So that kind of gives you the scale of it in the sky if you're not familiar with it already. And I'll highlight a few other things in the area too before we're done here. But if you look at the big square, so in Greek mythology, this figure represents the great flying horse Pegasus. And interestingly, there's only half a horse, so he's upside down. This is the big square represents either his wings or his body, depending on how you want to talk about it. His head, his neck, and his head extend to the west like this. and end at this bright reddish star Enif, which is his kind of nose. His two forelegs extend up from the star Shiat, kind of in this direction. And then Alpheratz, which is kind of the, you might think of it as third base in this view, it actually is shared between Pegasus and Andromeda. And if you can tell on the zoom here, but there's Alpheratz. If you hop down a star and another star and look up, there's the Andromeda galaxy right there. So if you ever need to find the Andromeda galaxy, you can either use this sort of stepladder of Andromeda or use the top half of Cassiopeia, which kind of makes a big arrow pointing here, the galaxy here. That's where you need to find it.
I'm sure this has been said multiple times before, but that is a spectacular first attempt with a pair of binoculars. If you've never used binoculars to observe before, that's a great one to try to find. It was the first one that I ever found, first target that I ever found in binoculars, and I still remember it to this day. I didn't believe it, and I just immediately took the binoculars down. I was like, nah, that was an accident. That wasn't real. If I find it again, maybe it'll be real.
Oh, yeah. And in fact, what's great about this patch of sky is that you've got, you know, a couple of really great binoculars objects. I'll highlight another one here in a minute. But yeah, it's well worth catching. Obviously, the higher Andromeda is in the sky, the clearer it'll be, and the better. So at this time of the year, you know, 9:30, it's not that high yet, but it's getting there. So if you're out, you know, 10:30, 11, late night, and then wait a few weeks, it'll get higher and higher as we go. Really great. Yeah, really great for beginners to check out. And that's not a bad object to nab for your kind of first binoculars object. I mean, a whole galaxy, that's cool. So yeah, back to Pegasus, a couple more things about Pegasus before we move on. When you're seeing the big square, in the sky, it kind of looks empty at first glance. There's not much happening inside of it. But you will notice there are a couple of stars kind of offset from the middle. And in the indigenous traditions, you know, they feel that these stars, in the Canadian indigenous stories, they feel that these stars represent the moose. And they actually use, they correlate, you know, when Pegasus is visible in the sky with when you're allowed to hunt the moose, that sort of thing. So when Pegasus hides in the spring, then you don't hunt the moose because they're raising their calves. But when you're seeing the moose, you know, in the autumn sky, then it's fair game. So it kind of, they obviously take lessons from nature and they incorporate these stories. But one of the coolest fun facts that I've learned from, you know, indigenous storytellers is that these two little stars inside the square represent the moose's heart. And I always thought that was really cool. Now, just one final, you know, twist on this is that in the pre-Islamic, you know, Arabian Peninsula, the pre-Islamic astronomers, they saw this as a horse as well. And a lot of people think that the reason it's a half a horse is because it's not meant to be the, you know, the living, breathing horse. It's meant to be the carved horse on the prows of ships, which the Phoenicians used to carve horses on the prows of their ships. And so this half horse would represent the prow of the ship, which is kind of a fun thing. And yeah, so that's why the rest of him is missing. And in the Islamic tradition, the square represents an open water bag. So when they wanted to collect water from a well, they would use a skin bag and they would store it flat. But when they wanted to dip it into the well, they'd need to prop it open and they would cross sticks across the opening and make it a square opening. And then they could lower that down. And so the two little stars that I mentioned would be the heart. They actually represent the knots in that's tie the two cross sticks together. All right, so all that preamble said, let's talk about exoplanets. And if you look at the square Pegasus, you know, you're going to see Algenib at the bottom, or Algenib, Markab, Shiat, and Alpheratz, which is again your guide to Andromeda. And between Shiat and Markab, kind of between the head and the front legs, there's a little star just outside the box, about midway along the box. And that star is naked eye star. It's magnitude 5.4. So on a dark night, you can see that star, and definitely in binoculars. And that's designated as 51 Pegasi. And that's the very first star that anyone discovered an exoplanet around using I think it was the radial velocity method. So I was just on the Wikipedia page, and it's fun to read about this if you want to go. So Michael Mayer and Didier Queloz of the University of Geneva, I guess they studied the spectrum of the star and noted that it was red shifted, blue shifted over a period of time. I don't have all the facts and figures kind of memorized here, but the fact that something was tugging the star around was an indication that it was being orbited by something. And I guess eventually they worked out that it must have been an orbiting planet. And I believe it's a hot Jupiter planet. It's just let me bring up my notes about Pegasus here. I've got the note right here. Here we go. So, yes.
I apologize. I actually don't know much about this one.
Yeah. Every 4.23 days was the period of the oscillation that they detected. And they believe that it's a planet about half the mass of Jupiter, orbiting about as close to its star, maybe a little bit closer to its star than Mercury does. So that makes it a hot Jupiter, as they call them. And so originally they wanted to name the planet, I think, Bellerophon, which is one of the riders of Pegasus in mythology. And but instead the American Geophysical, sorry, the IAU, International Astronomical Union, have given it the name Dimidium, which is a Latin word for half, since it's half the mass of Jupiter, I guess. And they've now given the star name Helvetios. And I don't know if I have what Helvetios comes from, but anyway, so if you want, you can, any night, you can get out there, look at the square Pegasus, and easily locate the star and know that there's a big hot Jupiter planet around it. I always think that's kind of cool.
Apparently the name Helvetios is Latin for the Helvetian, which is a Celtic tribe that lived in Switzerland.
Very good. Very good. Cool. Now, just while we're here, and yeah, I haven't got this one set up to show exoplanets, but talking about binoculars, I've got the Andromeda Galaxy sitting here. And then right up in here, you've got the double cluster, which is also fantastic in binoculars. Let me just simplify the map here for everybody. So, actually do this, dial this down a little bit. Let's see if that's good enough. There we go. These two yellow dotted circles represent the double cluster. And in binoculars, this is amazing. So they'll put a binoculars field of view on here so you can get a perspective on the scale of things. There you go. So the green circle would be the field of binoculars, and then the double clusters here. I'll just take out the declutter. You can see these two little knots of stars. And I think I could bring up the deep sky survey image that'll make it a little better. It's not the greatest view, but there you go. I turned off the daylight. So that's another really cool thing to look at in your binoculars, double cluster.
That's very nice.
Yeah.
I feel like sometimes stellarium's stars, I don't want to say overstate what it's going to be, but it's nicer to see some of the more subdued versions because it fits more with what you actually see in the binoculars.
Yeah, I recommend, regular viewers know that I commonly use this deep sky survey image because lots of the objects in stellarium don't have a photograph, but they'll be revealed if you use the whole sky survey image. But that's a great one to use. All right. So why don't you let folks know what the RASC was doing with the robotic telescope? I think that's a cool.
That was so back up until relatively recently. RASC was using a robotic telescope in California to teach high school students how, and actually some RASC members, how to find and image exoplanet transits. We came up with the program back in, I think, maybe late 2021 or so, or maybe late 2020. And it was really effective. We had a couple groups of high schools doing this sort of advanced program where we would teach them how to find predictions about what exoplanets we would be able to see. Now, the way that works is, and I think I've mentioned it on the show before, if you have a star and it's shining light and you have an exoplanet coming by, in this case, it's going to be vertical, you get the idea. It'll dim the star for a second and then it'll brighten up again. So that's how that's how many people will discover exoplanets, is they'll see the planet orbiting past the star and the star will dim for a second and on a regular interval. There are other ways too, as Chris mentioned. There's the radial approach, which is sort of looking at the color of the light that comes from the star and how it shifts as the planet wiggles around.
Detecting the to and fro
towards
a wave wobble.
Yeah, which is very neat. It requires slightly more specialized equipment. The cool thing about using the method which I just showed you, which is the transit method, is you can do it with ground-based telescopes pretty easily. And so we were teaching high school students how to go into databases to look up which exoplanets we were predicted to be passing in front of their star at specific times. And we'd program that into the telescope with them. They would get the data back and they would process it all themselves. The reason we chose to do it that way, which is a very complicated way to do it, and it's fairly advanced for a high school program, is because I don't know about everybody else. Certainly in my experience in high school, there wasn't really a good understanding of what science actually was. You read through textbooks and you had people tell you stuff, and that was sort of what science is. But when you get to university, then you start to realize that science is like pushing the limits of that stuff and learning new things and contributing in that way. And doing these observations felt more to me, and I think to the students as well, like they were actually participating in gathering new research and doing new science, not just repeating the same kind of lab programs that everybody else did. And the thing that was special to me is that they could compare their results to the prediction from what math told us would happen, but they couldn't compare their results to anybody else. Like they couldn't go back and look at the previous year's classes. Like classes data and compare it to that. They had to kind of do their own thing. So that's how it started. We ended up making a couple programs where we had like data sets available for students to use that were already processed, because there was quite a bit that goes into it. And I believe eventually they were working on a photography one, and one class even did a program looking at targets of interest, which are not actually necessarily exoplanets. They're things that some telescope somewhere has seen. Like the algorithm, I say that like it's a one thing, but an algorithm has figured out that there's a dip and it might be regular, and it's got maybe a prediction of when the next dip in the brightness will be. You can look through those databases and maybe image something that's an exoplanet, maybe image something that's not, sort of contribute to that field of knowledge. And I brought this up while we were chatting. The particularly cool part about this, and this is exciting for me and I think exciting for some other folks too, one of our classes that was working for years, it was a school club, was working for years on this project. They published their results from it in the journal, in the RASC journal in June. So if anyone who's a member and has access to the journal wants to read it, it's fairly science heavy. I'll have to leave my emails there. This is the June issue of, the August issue of the journal. And this is their article here.
Nice.
So this is where, and their club teacher representative is Mark Eden, and these are all the other students who are in the club. And they did a target of interest. So if anyone is interested in reading about the results from the RASC robotic telescope and what these students worked on, it's in the journal. I'll send this link. It's password protected, and you do have to be logged in as a member to see it. But I'll send this link in the chat in case anybody's interested.
Cool. Very good. Yeah, well, I think it's really interesting how the different techniques are most appropriate for different situations. So the radial velocity method is really biased towards a planet that's heavy enough to tug its host star around. So you're really going to find a lot of big Jupiter type planets, and also, it has to be happening on a time scale that you can reasonably, measure, that you don't need forever to take the data for. Same with the transiting method, the exoplanet methods. I mean, it's great if it's hours long or something like that, where you can do it kind of on an observing run.
Mhm.
and record that dip. But there's going to be lots of planets that are orbiting stars that take a lot longer. Imagine how long the transit of Neptune across our sun would take for somebody looking from a distance. I mean, it would be, practically unmeasurable because it would be so slow. So we have a lot of bias. We're
Mhm.
finding the easy stuff, and then we only have one sample to extrapolate from using our own solar system. So we say, well, we have, three or four, four terrestrial planets relatively close to our sun that would transit our star relatively frequently in a short amount of time. And then we know we've got a whole retinue of other planets in addition to that. So we just sort of have to tally up and estimate.
Yeah, I have a couple points on that. The thing that I always find interesting about when we gather information about science is that every single time, it seems without fail, we go, oh, well, this is the way it is here. So obviously that's the way it is everywhere else too, right? And so we started off, I find the naming for exoplanets to be kind of funny. That was like, okay, well, we have Earth-like planets and we have Jupiter-like planets. And it's not a description of what the planet is. It's just sort of like a comparison to what we have. And then we have stuff that doesn't fit in with what we have. Okay, so we're making up new things like a super Earth or a hot Jupiter, or like all these sorts of things that are slightly different from what we have, but we didn't really know they existed. I think it's very sweet that we just keep going. We're so focused on our little group of things here. We don't really make up new names for stuff. We just use the stuff that we already have.
One of the things that I try to be careful of when I'm writing is not to say, Earth-like when I mean Earth-sized or Earth mass or something like that. Because when they say Earth-like, they have no idea if it's like this. They just know that it's, about the same size and about as far from its star maybe, and about as massive. And of course, that's what's cool about all these techniques, is that you can find, you can get a sense of a planet's diameter from a transit, from a well-defined, relatively noise-free transit. You can detect an atmosphere evidence by the slope of the edge of the transit, edge of the dip, all kinds of things that you can add on to.
Yeah,
So, we find, bigger, less dense planets, smaller, heavier planets, all kinds.
And it's getting more and more complicated too, as we start measuring the color of light that is blocked by the planet as it transits in front of its star. So for example, I think if Earth transited in front of the sun and someone far away was looking at it, we would block more light, correct me if I'm wrong, in the blue part of the spectrum because our atmosphere is blue, or we'd let more through that's blue and we block the other colors.
The ring of light passing around the Earth would be the sunset colored light, right? So that would be,
right,
potentially more reddish.
So blue would be filtered out.
But the point is that if you take the spectrum of our star, when there's no planet in the way, and then you take the spectrum again when there is a planet in the way, and look at the differential, then you can start picking up things like, oh, there's oxygen and there's other things in the mix that aren't there all the time. So yeah, it's for people getting into the field, when I was younger and getting into astronomy, it was basically stars and nebulas and galaxies. Now there's a whole group of people that can just devote their lives as astronomers to planets and discovering them and characterizing them. And then you get into exobiology and all kinds of other things. So yeah, it's exciting times.
Yeah, very exciting. There's a comment from Warren that I don't know the answer to necessarily, but I do have a comment about direct observing. He says, wasn't there a photographic method in the 1960s who measured a wobbling really nearby star?
So yeah, I'm not sure which case you're talking about, but I do believe that some Canadian investigators thought they had potentially discovered an exoplanet years ahead of that, 1995. But they weren't able to be quite as confident as they wanted to be to publish the results. So they didn't really get the credit for the first, if I recall the story correctly. I mean, it's worth looking up. But yeah, I think Canada has a connection there.
And then also talking about photographic methods of looking for exoplanets, because we've seen a few that have been detected with photographic methods. And I don't know for sure about James Webb, but I feel like that's a potential for James Webb as well. Chris was talking about the bias in what we see based on the way that we sample it. So for things like the radio, what's the word for it? radial velocity. There we go. Sorry, radial velocity, the method of looking at the radial velocity. That shift in light, we only see the shift in light, red shifted or blue shifted, as Chris was mentioning, because the planet is moving quickly towards and then quickly away from us. If the planet on this kind of plane, so the planet goes zoom towards us and then zoom away from us, and we see the shifting light that way. If the plane is like this, sorry, this is whatever, closest prop I had. If the planet is going around the star like this, or the star is wobbling like this, the speed doesn't change of the star relative to us, so we don't see the shift.
Exactly. So that planet's invisible to us in that case.
Yeah. And same goes, but then again, if we have a planet and a star system that is on this plane that's close enough and with telescopes powerful enough for us to directly image it, this is one of the few ways in which direct imaging really works, because then you can block out the star in the middle and see the planets all around it. Whereas if it's more like this, it's a lot harder to see a planetary system that's on this kind of angle with just a photo.
Yeah, so what makes that really interesting is that, you know, when it came time to assigning telescope time on some of the big observatories to researchers, you know, there was a time where planets didn't get as much love as they deserve. But now that we think virtually every star hosts planets, it's almost pick a star and image it and use the infrared or use the visible and see if you can pick something up. So I think a lot of the nearby stars are going to get lots and lots of love and attention on that basis for sure.
Yes, I bet. Yeah, it's an exciting time to be in this field for sure.
What was this question? Are there pictures from
No. Our sun and the Earth blocking our sun.
Yeah, we haven't been able to get far enough away from our solar system to look back and to do that sort of effectively. I don't know if one of the fun things I've done in the past on Insider's Guide is looked at, if you were to park yourself on, say, you know, Europa, could you see Earth transiting the sun at some point in the future, you know, in a space tourism sort of thing? And you can find those out. So, you know, transits of Mars, transits of Earth, things like that, they work. And, you know, theoretically, the transit of the Earth would have a little moon with it. So you'd have a little double transit across the sun.
Yeah.
That would be fun. Future Martians will have that sort of fun now and again.
And we do have photos. I think we have photos of a lunar eclipse from the moon. Do we have photos of that? Or does
a lunar eclipse from the moon? I don't think so. No? I don't know. Okay. I would have thought that would be pretty spectacular, and I don't remember seeing that. But
that's true. That would be sprayed all over every single space website.
That'd be a poster I'd want. Yeah,
that would be a poster.
the sun's halo around the Earth as viewed from the moon.
Yeah, maybe someday when we get to space tourism and we get to the moon and all that, that will be one of the things that you go to the moon for, is to see all the sunsets on Earth at the same time.
Well, that's sort of another thing that, and this we could have done a topic on this one day. One of the things that I think is cool about space and unique about Earth is, you know, I don't necessarily believe that aliens are visiting Earth just because space is so big and it's hard to get from place to place. But where else do you have a situation where you have a moon that's exactly the right size to eclipse the star the way we do? No other planet in our solar system has that happening. We're the only one like that. And not only that, but it's just nowadays, in the distant past and in the far future, the moon won't be the right size to produce the solar eclipses that we get now. So, I mean, that's a reason why space tourists might want to come and visit Earth just to catch a solar eclipse.
That's true. It is very special. And for those, I'm sure we've talked about this, and I'm sure you've talked about this before on the show, but that's like the fact that our moon and our sun appear to be the same size, that the moon is 400 times smaller, but 400 times closer or something like that. That's entirely a coincidence. And earlier in our Earth's history, the moon was closer to the Earth, making it look larger than the sun in the sky.
That's
and then
right.
It's slowly drifting away, right? So it'll slowly become smaller. And already the moon doesn't always completely block the sun. When there are solar eclipses, the solar eclipse on October 14th will be one of those where the moon is slightly further away from us than usual. And so there's the ring of light around the sun that doesn't get blocked by the moon.
That's right.
Which every every time I talk to astronomers, I was thinking about traveling for that. I won't be able to, but I was hoping to go to Utah. And they were like, oh, why would you travel for an annular solar eclipse? I was like, leave me alone. I just want to see cool space things happen.
Why not? If it's convenient to get
Exactly.
there. Yeah, that's what's neat is that eventually all eclipses will be annual. There will no longer be total solar eclipses.
Kind of sad.
Because
Enjoy the total solar eclipses while you can, everybody.
and I don't know if people know why that is, but I can explain it briefly. It's
Yeah.
because, as the Earth rotates and the moon orbits above us, the mutual gravitational between the two bodies produce a bulge on both objects. And those are the so-called tidal forces or tides that rise on the Earth. As the Earth rotates underneath where the moon is, then that tidal bulge kind of sweeps across the Earth to stay under the moon, if you like. There's a bit of a lag, but that's basically the way it works. And so what happens is that the Earth is turning faster than the bulge has a chance to migrate back under the moon. So the tidal bulge is always ahead of where the moon is. And what that causes is that bulge is actually pulling on the moon and wanting it to speed up to keep up with the bulge as the Earth turns. And so that speeding up of the moon's orbit increases its energy and increases its orbital radius. And so that's why the moon is getting farther from the Earth. I think it's about, what is it, a centimeter or two per year?
Yeah, something in my head says
I think it's
4
about another cool fun fact. This is the day of fun fact, is that the Earth gets farther, the moon gets farther from the Earth in about the distance of a human growing up. So maybe the height of a human in about 50 years or something like that would be about the same. And the other is that the continents are spreading between Europe and the Americas at about the same rate. I think also that's the rate the fingernails grow. I think somebody else said that it's about that same rate too. Fun, all fun
What
stuff.
a coincidence. And it's 3.78 centimeters per year, just under about an inch and a half. So it's yeah, close. That's so cool. Neat that they all kind of intertwine like that. Either way, it's not, I think sometimes the news gets away with this stuff and is like, oh, the moon's drifting away from the Earth, everything's going terribly. And it's like, it's moving very slowly. It's not going to go far in our lifetime. And we will still have total solar eclipses in our lifetime for sure. It'll take,
oh yes. Oh well, it'll take a long time for it to evolve out of that. But it's kind of it's one of those interesting thoughts about the universe at the time we exist in it. We, as I said, we live in a time where we can experience eclipses. Our distant ancestors may not get them unless they travel to set them up, that sort of thing. The other thing is if you ever read about the far future, state of the universe, in long enough time, in trillions or billion trillions, I'm not sure the time scale, the expansion of the universe will cause all the galaxies to be too far away for their light to ever reach us. And so at some point, the only galaxy we'll be aware of is our own, which is also kind of a fun thing. And, future cosmologists will be unaware of the existence of the rest of the universe unless somebody tells them or it's recorded, in the annals somewhere. So that's really kind of interesting to think about that.
So strange.
Yeah.
Yeah. Huh.
Yeah. So if anybody has questions, I'm happy to try to field anything that you have. While you're doing that, I'll just remind everybody about tomorrow night's super blue moon, which won't look blue. Actually, I was out last night at the DDO leading a sky tour, and the moon looked a little bit brown. So that's more likely than blue. And we talked about blue moons on a past episode of Insider's Guide. It's under one definition, it's the second full moon within a calendar month. So when the moon is full within the first day or two of the month, except for February, then you can have a full moon again. So that's what this one is. The other definition is that in a season that typically, a season of the year that typically includes 3 full moons, you get a fourth one. And in this case, the blue moon is considered to be the third out of the fourth. And the reason is that usually the first full moon of a month or the last full moon of a month is used by to time some cultural event, like The first moon in the spring is used to control Easter and Passover. So it's called the Lenten moon or the Paschal moon. And then there's the moon in December is the moon before Yule and the moon after Yule. So if you plug in a blue moon in there, then it can mess up the names of these special moons people use. By putting it third out of 4, it never bothers anybody. And so the one on Wednesday night satisfies both criterion. It's the third of 4 in the summer, and it's the second of 2 in August. And it's a supermoon.
And it's a supermoon. A reminder though for folks, because I've been seeing this on social media and it bugs me, the moon is not, as Chris said, not actually going to be blue, but people keep photoshopping it anyway.
Oh yeah, I've seen that.
There's a quick question from Linda saying it's been red and growing each night here in Alberta. Is it smoke? And yes, if the moon is looking red or orange, and if the sun is looking particularly red as well, it's usually smoke from forest fires that is causing that. It can be dust too, just like general dust in the atmosphere. So if you're near a desert and there's been a lot of wind, I think that can also turn it red. But for the most part, it is the smoke particles filtering out the other colors of light.
And often it's, certainly in Southern Ontario, it's usually dry in August, which it hasn't been that dry this year, but usually it's drier in August. And when the farmers start working the fields and harvesting the crops and kicking up a lot of dust, that can also make a layer that if you catch the moon just when it rises, it's sort of shining through that additional dirt in the atmosphere to tint it a little bit too.
We have a very fun question from Wayne. I love these kinds of questions. If you lived on the moon, come back. If you lived on the moon, would you see a total solar eclipse? Would you see the same phases of the Earth as we do of the moon? And would there be things like a super Earth?
So yes, no, yes, I think is the answer to the question. So no, it's no, yes, yes. So you would not see a total eclipse if you lived on the moon, because the Earth would be far too big to create the ring of the corona around the sun. You might get a little of it.
Okay, this could mean two things. Because it could mean a total solar eclipse with the Earth being the thing that's eclipsing the sun, and then you would see it would just be dark. So you would get that.
You'd get partial solar eclipses, when the sun is beginning to be covered by the Earth or finishing. Yeah.
And you would see a lot of red light, I think, from the light scattered through the atmosphere, which is why when we look at the moon during a lunar eclipse, it looks red. But then there's also, if you're on the moon while there's a total solar eclipse happening on Earth, then you would not see it. You would see the shadow on the Earth, but you on the moon would not have much happening to you, right? The moon is blocking the light from the sun.
Yes, so it would be nighttime on the moon where you are during a total solar eclipse visible from Earth, and you could look down on the Earth and see the shadow. Yeah. I believe that's true. Sure. Yeah. So that was one question. The other question was, let's go back here. So the Earth would show would show similar types of phases that the moon does, but I think they're kind of reversed. I haven't thought about this exactly, but when you'd definitely have new Earths, full Earths, half Earths, crescent Earths, gibbous Earths,
and then the ground under the shadows and light would be spinning.
Oh, the Earth would still be turning at the same time, but the percentage of the Earth lit would vary every night, and would be on the same schedule, the same synodic schedule, I think, as the moon's is. And finally, super Earth, yes, in theory, because the moon will be closer and farther from the Earth at different times, then you would have bigger Earth, smaller Earth slightly. Yep.
Okay.
So no, yes, or maybe yes.
We also have a question from Claude in the Q&A, which is, do people with their own telescopes ever link them up to make a super wide array amateur telescope? Because we've done that with big ground-based telescopes before. And I think, yes, Chris, I think in hunting for asteroids, right?
What was the question? Is it trying to make an array? Where's the question here?
Yeah, so it's in the Q&A. So do people with amateur telescopes, like amateurs with their own telescopes, link them up to make a super wide array amateur telescope? And I would guess this is a bit of a technicality, but linking them up would be more like just looking at data from the same time frame.
So yes, you can do very long baseline array astronomy, particularly with radio telescopes in different places. That's how they got the image of the black hole event horizon. Basically the telescope is as big as the Earth is. And there have been cases, I believe, where two smaller side-by-side optical telescopes looking at the same object have transmitted their data, their imagery, to a computer process which was able to manipulate the results and produce an image that kind of is better than the single, better than the sum of the parts kind of thing.
Mm-hmm.
But amateur-wise, no. What you basically need to be able to do is feed the same image at the exact same instant into the algorithm, and that would be tricky for amateurs to be able to all link up and do that sort of thing.
But some people, don't they, when an asteroid is about to pass in front of a star, sometimes they'll get people in the like pathway to try to image that time frame all over the place to try to determine how big the asteroid is and what the shape of it is, right?
Yeah, that's a great one. So, I mean, you don't even really need a telescope per se, but yes, in that case, if everybody's observing the same event and carefully noting the time when they saw the event happen, then you can start producing build geometry about the situation. And in this case, you can sort of trace out the shape of the asteroid by when everybody saw it disappear and reappear. Yeah.
Which is pretty cool. It's not just shoving it into an algorithm. I think it's for the most part sending it to a person, but it's close. It's pretty cool.
Yeah, I'm not sure. I guess there are repositories that would actually receive your observing report on your sort of asteroidal occultation event or something like that, and be able to generate some of the revised shape model for the asteroid. Yeah, it's really a cool, fun thing to think about.
Quickly, John Silasan or Silasan said that's what IOTA does. So maybe that's one of the people.
Yeah, IOTA is the International Occultation Timing Association, for those interested.
That's neat.
Yeah, and they have a great website. If you go to IOTA, not sure whether it's .com or .org. I use it all the time. So when I'm writing my month, what's coming up this month, I'll see a reference to an occultation, and IOTA will have it listed. And then usually there's a link that lets you see the map on Earth where it's visible from, things like that.
Okay, I think I found the website.
New Horizons for Crude Amateur.
Couple comments, etc. I'm enjoying this. I know that this is not typically what an Insider's Guide to the Galaxy has been lately, but it's nice to just kind of like hang out and chat.
It's potpourri.
Yeah, it is. A little bit of this, a little bit of that.
Well, we will switch over to our more formal finest NGC here in a few minutes.
Yes, that's true. Mitch was curious about your insight on India's successful landing on the south pole of the moon. Do you have any insight into the probability or extent of the water to support future moon stopovers for longer excursions to Mars or whatever?
I haven't done a lot of research or reading about it, but kudos to India for joining the community of countries that have successfully soft landed on the moon. That's really, there's kind of a space race to the moon's south pole, because they expect to find water ice frozen in the deeply shadowed craters that would then be great for supporting human exploration and long-term presence on the moon. The water can be used both for drinking and human benefit, but also the water can be used to split into hydrogen and oxygen and then form rocket fuel. So if you don't have to take quite as much fuel or water on a trip, then it's great. It's called in situ resource utilization. It's what the big keyword buzzword is. You'll see lots more of that. That's what Artemis is going to be all about as well. Once they start landing in the South Pole.
It's exciting stuff. There's a question from James. I can never get your last name. Amandologine, I think. Hope. In the chat, which is, are there any RASC groups meeting up in Texas to go see the solar eclipse? I know there are RASC members, but we haven't formally organized anything. So I would recommend, if you are a RASC member and you're curious about going to somewhere to see the solar eclipse that's happening on April 4th or 8th, 2024, Texas is right in the path. It's a very popular potential destination because it is relatively easy and it's dry. Mexico's in the path too, I believe. Newfoundland's in the path, less popular because, you know, it's Newfoundland and it's cloudy and rainy a lot in April. I still like Newfoundland. We'll see. Anyway, so I would recommend if you're planning on traveling to see the eclipse, post in the Rask, like the Rascals chat, or if your center has a local chat, post in there and see if anyone's going. I think it'd be nice to meet, if you have the chance to meet up with people, to do so. Rask National isn't planning anything in particular. I don't know where I'm going to be. Chris, do you know what you're going to do?
No, I don't, and I'm getting a little nervous. Yeah, I'm gonna have to get onto that pretty fast. I know that Toronto Center has organized a trip, but their trip is full because of the limitation in availability of hotel rooms. That's basically the big limitation in some of these places. Yeah, the eclipse is gonna make landfall near Puerto Vallarta, Mexico. So sweep across the northern section of Mexico and then kind of straight across Texas. So a lot of the big cities in Texas are on the path. And then it'll come up through the eastern half of the continental US, through Oakville, Ontario, but not Toronto, parts of Mississauga, I think. You know, if you're on a boat in Lake Ontario in April, you can see the path of totality if it's clear, it's not raining. And then it sweeps across, you know, Buffalo, Rochester, the southeastern piece of Quebec, south of the St. Lawrence.
And Montreal. Montreal's in the path.
Parts of it, I think, not all of it, maybe.
Really?
I thought it was only parts, but I'm not sure. And then,
it goes through
it
New
sweeps
Brunswick.
across New Brunswick, I think, and then hops over to Newfoundland, kind of a piece across the center of Newfoundland.
It's very exciting. I also don't have plans. I also am nervous. I'm planning on just, I don't know, driving somewhere to where it's clear, maybe. I don't know. We'll
I work a lot with people, educators in Texas that use the planetarium quite a bit. So I'm hoping that maybe someone down there will invite me down or something like that.
That'd be nice. That'd be nice.
Yeah.
And I think the last question before we get into the finest MGCs, the last of the finest MGCs, is, I don't know the answer to this one. I don't know if you will, Chris. Has anyone been able to take 3D images with multiple telescopes set over a large distance of anything in space?
Like a stereoscopic picture from,
I think
you know,
what
two pictures at once.
Yeah.
Yeah, I mean, I think we do that. We do that. Well, there's a couple of different techniques that you can use. One is if you've got two spacecraft with two cameras and they both snap a picture, you know, at two separate places, then they kind of simulate your eyes separated and you can make a stereogram out of that. But the most common technique that's often used is if you've got a spacecraft orbiting a planet, you go snapshot, snapshot in succession. And it's effectively the same, almost the same as two different cameras on two different spacecraft, because it's just speeding along over the planet. You've got all these pairs of images as you orbit the planet. So I think that's been used probably for some Martian imagery and some lunar imagery. Would be surprised. Yeah.
There's the one, so I just quickly searched, and there are stereoscopic images from the Lunar Reconnaissance Orbiter. Not quite a telescope, more like a space camera, but I mean, where's the line between those two? So yeah, I feel like if we're taking ground-based telescopes, you'd have to have the ground-based telescopes really far apart or the object really close by for it to make any sort of difference. Just because the objects in space are really, really far away.
Well, I mean, not like a stereogram image, but we use the fact that the Earth orbits the sun to measure how the stars change their apparent position and use that to estimate their distances from us by using their parallax shifts. That's kind of almost the same idea, where you're taking a photograph of a star field at one time of the year, and then 6 months later, the Earth is moved by twice the orbital diameter, 300 million kilometers. And then you can sort of see the difference. So the stars that are closer to us will apparently move a little bit, and the ones farther will move less, if at all. So
we need somebody to make one of those, those images where you can like cross your eyes and see the two pictures. Someone, amateur astronomers.
I've seen books. I can't remember the authors at the moment, but there are books that are basically anaglyph. I think they're called anaglyphs with the red and green glasses. If I may not have the word right. Where you wear those glasses and you can look at an astronomy, an atlas, star atlas, and you can see the stars that are closer and the stars that are farther.
That's pretty cool.
It is pretty cool. Yeah. All right. I think we
Okay.
should switch over to our finest NGC.
Let's do it. Yeah.
It's been a while since I actually wrote these notes, so hopefully I will be not too rusty here. Here we go. Share my screen up. I'll just turn off. Let me just prep a couple things here. Do that. Do that. And just by the way, going back to some of the comments earlier about, hoping that something like Insider's Guide can continue in some way, I'll just encourage you to be bold, make the attempt. You'll learn so much doing it. So it's definitely worth trying to teach others about astronomy by learning about astronomy, and you'll learn so much. So that's kind of a neat sort of benefit to doing it. Okay, there we go. Let's see if I can do this. Put this away. Bring up my notes, and I'll share my screen. I think by now I'd have this, it'll be second nature, but no. All right.
I don't know about you, but I always find that I have to narrate the steps, otherwise I forget them.
So the big announcement is that we actually have reached the very end of the list of the finest NGCs. This is the final group of them. We actually missed a few of the autumn NGCs at the beginning, so we've picked them up today. So this today is a mix of a few leftover summer ones and a few previously skipped autumn ones. And so what we've got here is the situation in the sky is that we've got a full blue supermoon, a full not blue supermoon tomorrow night. So obviously I'm not suggesting everybody go out and tackle the finest NGCs for a bit yet, but a week from now, we'll be heading into the lunar third quarter phase. And so we'll get nice dark evenings and then even darker skies for about a week beyond that. So, get ready, get yourself ready and head out, once the moon kind of departs the scene here. And you can see here from the shared screen, we've got objects that are primarily in the Cygnus region, kind of Cygnus, Cepheus, and up near Polaris. And so let's start. First one I've got to mention is, just bring this up here like this, is NGC 6826, which is the Blinking Planetary. And if you've not looked at the Blinking Planetary Nebula, it's really cool. So what it does, let's turn off my Deep Sky Survey image. Here we go. So the Blinking Planetary is a must-see, as I've said in my notes. It's small, it's bluish, it's bright enough to see in binoculars, but it just looks like a star in binoculars. But where you really need to see it is in a telescope. Larger apertures will better reveal its structure, which is sort of shown here. And it was discovered by William Herschel back on September 6th of 1793, object class 4, number 73. And the way I suggest finding it is it's on the line connecting Deneb and Iota Cygni. So if you can see on here, here's Deneb, the bright star in the summer triangle. And there's Iota Cygni, which is kind of where the crooked tip of the kind of northwestern wing is. And it's right on that line between them. And then what you want to do is wind backwards. So find the last two stars in the wing and basically just jump by twice that span back towards Deneb. Jump by the same span amount, but in the direction of Deneb, and you'll pick it up. So it shares a field of view with this pair of stars, this double star here, C Cygni. So that's another clue that you're in the right neighborhood. And if I bring up the sort of telescope view of it here. So this is our typical 6-inch Dobsonian telescope with a 26mm Plössl lens. So it's about a 35x magnification. And there you can see the planetary is in the middle, and then the double stars is in the same field of view. And this one's great if you've got an oxygen 3 filter, because an oxygen 3 filter will suppress the genuine stars and leave the planetary nebula brighter, which sort of, basically gives you a I'm here effect. So you want to use that. Then once you found it, you want to really increase the magnification. In order to see the envelope, you want to crank up the power. So I'm just going to simulate here. Let's try what? 65x, still pretty tiny. So you might want to go up to say, 150 power or more. And let me just bring up the digital sky survey image and see if it's a little bit better. Yeah. So you can sort of see there's a bright center and then there's kind of a ring around that. And then there's even a fainter halo. So if you've got a big telescope in dark skies, you can look for this sort of secondary complexity that's in it as well. So the idea is that if you stare at the star, you stare at the planetary nebula itself. Let me just crank in on a little bit here.
Ooh.
You're going to pick up the central star, the white dwarf star that's illuminating the rest of the planetary. And the envelope will kind of fade from view. But if you then focus your attention elsewhere, the envelope will brighten up as your reverted vision kicks in. So you can actually look and glance towards and away, and it'll blink bright, dim, bright, dim, bright, dim, and blink. And it's not the only one that does that, but it's really a cool one to try. So try that trick, averted and straight on vision. You want to look for the central star. You want to look for any variation in brightness on the envelope itself, any color you might see, any shape, things like that. It's about 4,800 light years away. So that's a cool, really cool object. And let me go back here. Next one is another Shopi. This Jenna and I have a connection on this one.
Yeah.
Well, the next couple of these, because we were on the phone one night or on a call on a was that
It was I was thinking maybe we
that
could do
server?
this.
Yeah,
Yeah, we did. We're on our Discord channel and hosting
Discord
a
server.
remote observing night where we all just were on the voice chat and observing from our different locations because we were in lockdown. And it was awesome. It was the best.
Yeah, Jenna let us know that she was in some gloriously dark place while we were all stuck in Toronto. And so I said, well, while you're there, grab the binoculars and look and do the following and take a look at these things. So this is the North American Nebula. And it's located very, very close to the star Deneb. And in fact, if you get away from the city lights and you get the moon out of the sky, you can see the faint glow of that patch of sky just with your unaided eyes. Binoculars, no problem whatsoever. And then if you're using a telescope, you want to use your lowest power magnification because it's a pretty big object. In fact, let me just put my field of view indicator here. Look at that. That's the 150 power. You've lost it. It's just completely way beyond your field of view. So let's go back to the 26. So even on the 26, it's way beyond. But what you're typically going to end up doing is you're going to look for some of the distinctive features in it. So here's the idea. It looks like North America. So you've got kind of Mexico is a brighter section down here. You've got a dark dust in the shape of the Gulf of Mexico and a kind of a stubby looking Florida section. And then you can trace it up through Canada, kind of the Aleutian, the northern islands in Canada and back around to the other side. So it's really kind of looks like what it's called. And when you're exploring it, of course, you want to look at some of the internal structures, which I'll come back to. And then this dark dust separates the same gas into two zones. And this piece over here is called the Pelican Nebula. I don't know if you can see the top of the Pelican's head is here. His long beak or bill extends down to the left and then comes up. And then he's sort of the generic sort of hunched bird sort of look to it. So really easy, not very far from Deneb. It's actually only centered about, what is that? 3 degrees from Deneb, so a few finger widths. And try to look for the most distinctive section, which is the Gulf of Mexico. And once you've got that, then you find yourself able to nudge your telescope around and see the rest of it. So when you're viewing it, when you're logging it for the certificate, you want to note the various dark patches, the shapes, look for the pelican, look for some of the internal stars that are inside it. Some of the little, there actually are little NGC objects in it. I'm not sure. There's a one here. There's another one here. So those are something you can pick up while you're taking a look. So that's the North American Nebula. It's about 2,000 light years away. That's one of the reasons why it's so big. Next one I've got is in the same kind of neighborhood, and it's called the Pink Pillow Nebula, NGC 7027. So while you're on the North American Nebula, you can sort of navigate your way almost twice as far, you know, from Deneb as Mexico is. Keep going, centering your telescope. This has got a number of names, as you can see here: the Jewel Bug Nebula, the Pink Pillow, the Magic Carpet, the Green Rectangle, the Sugar Pops. I mean, who comes up with all these? This is an unusually shaped planetary nebula. I'll just zoom right in to show you. You're not going to see it as clearly as that in a visual observation, but it's really neat. So in binoculars, this one will also show up as a kind of a spot. It's magnitude magnitude 10 or so, so it should pick up in big binoculars. Large telescopes should be able to pick up its structure. Even a small telescope should be able to pick up its general shape. This is not a Herschel object, though. This one was discovered by Edouard Jean-Marie Stephan of the Stephan's Quintet fame, if you're familiar with the Stephan's Quintet galaxies. He discovered it in 1878, and it was then rediscovered again in a sense by Thomas Webb in 1879, so it doesn't have a Herschel number. It's on the southeastern outskirts of the North American Nebula, as I just showed you. And I've got it mentioned at about 1 degree east of the midpoint between the two stars, Chi, which is this star, and Nu Cygni. So where's Nu Cygni? So there's Nu Cygni. So if you see Deneb, look for Chi and Nu, these fainter stars, and it kind of forms a triangle between them and a little farther from Deneb. So this one will also benefit from the oxygen 3 filter. Averted vision will help with this one. You want to use lots of magnification, maybe 300 power if your seeing conditions allow it. Try to see its central star, try to see any idea of its sense of its shape and orientation, any color you might pick up. And this one's about 3,000 light years away. All right, next up, we've got the Fireworks Galaxy. There's my Fireworks Galaxy. That one's up here, kind of on the border between Cygnus and Draco and Cepheus. There we go. I'll just zoom partway in. This is a magnitude 8.9. It's a little bit brighter than actually Stellarium says it is. Some of the magnitudes are not, Stellarium is a little off on some of them, but I usually like to go into the SIMBAD database and look at the researchers' calculated or average brightnesses and distances of these things. So this one, the Fireworks Galaxy, it's also known as Caldwell 12 under James Moore's list, Patrick Moore's list. This one is a relatively close face-on spiral galaxy. There it is there. This one helps to have dark skies, moonless skies. And this one actually would be brighter than it looks, if not because it's so close to our Milky Way that our Milky Way gas and dust are attenuating the light from the background galaxy farther away. A smaller telescope should be able to pick up its core. And then if you've got a bigger telescope, you can see more and more of the structure in detail. You know, say an 8-inch or up would be really good to have. And you can try to look and see if you see the kind of knotted, clumpy arms that are fairly well separated. So see how much structure you can tease out when you're looking at it. This one was discovered by William Herschel back on September 9th of 1798. It's class 4, number 76. And it's located near the bright star Alderamin, which is part of the box of Cepheus. And I said that it forms a near isosceles triangle. So if you find Alderamin, you can look for these two stars, Alcider and Cabelford. Sorry about pronunciation butchering. And then the galaxy makes a right angle about that same span to their southwest. So don't use a filter on this. You don't want to use filters on galaxies, but you do want to use averted vision. You want to use patience to tease out its shape and structure. Start out with low magnification and work up. So there's your 35x kind of view, which is perfectly fine. And then while you're in the neighborhood, there's also another open cluster called the Ghost Bush Cluster, NGC 6939, in the same area. And speaking of that, that's our next finest NGC, the Ghost Bush Cluster. So you get a 2-for-1 when you do these ones. So you find it basically the same way. Let me just wind back and show you how this works. So remember I talked about the bright corner of Cepheus, the two medium bright stars sitting off the corner of it, and then it's almost the right, a little bit less than the right angle. So you might, not sure which one you're going to tackle first, but they're both in the same basic area. So this one's also called the Silk Fan Cluster because it's got a really neat sort of spray or shape to it. Let me just bring up the deep sky survey image. There we go. Can you kind of see I don't know if it's as apparent in here, but it's kind of got a kind of a wedge shape to it. This one was discovered by William Herschel on September 9th, 1798, basically the same night that he discovered the fireworks one. It's class 6, number 42. And it, let's see, you want to use averted vision to pick up the finer stars in it. So it's got a mix of bolder stars and fainter stars. Note the distinctive V shape or any other patterns or asterisms that you might notice. Note the colors of the various stars and how many you're counting of sort of each population. And this one's about 5,700 light years away. So that's your 2 for 1 on that one. All right, a couple more here. Going back. Now we're going to hop into Cepheus. So we've got NGC 7129. This is called the Small Cluster Nebula or the Cosmic Rosebud Nebula. And it's actually a reflection nebula, one of these bluish reflection nebulas with stars embedded within it. This is one of Canadian astronomer Sidney Vandenberg's reflection nebulae from his list. It's Vandenberg 146, as you can see up here in the notes. You're going to see some faint bluish nebulosity around a group of bright stars. And the better your telescope, the bigger your telescope and the darker your sky, the more extensive the nebulosity will grow. William Herschel picked this one up on October 18th of 1794, class 4, number 75. And it's inside Cepheus's, boxy shape, kind of midway between Alpherk and Alderamin, and just inside, the distance in is about 2 degrees or 2 finger widths just inside. Let's turn this one off. And I noted that there's a kind of a mini Southern Cross asterism between this. So if you kind of look for that mini Southern Cross asterism and then sort of slide halfway back to the line joining those 2 stars, you should be able to pick it up okay. Let's see. Oh, and there's a couple of this nice pair of stars is in here as well. So filters won't help much with reflection nebulae because reflection nebulae are scattering starlight. And if you use a filter that suppresses stars, then you're going to suppress the reflected light somewhat as well. So you can try with and without. I think I reported that the filter did help a little bit. Maybe it was just darkening my sky enough to help me see it, but try with and without. Averted vision definitely will help a lot. You want to try various amounts of magnification. So this is, again, back at only 35 power. So it's a pretty extensive object at low power. You want to describe its shape, any structure you're seeing, the pattern of stars within it. And there's also another open cluster nearby I've got noted here. Let's bring this one up. Yeah, NGC 7142 is a little open cluster just to the southeast of it. This one's about the Vandenberg, the reflection nebula is about 2,500 light years away. And finally, last one of all is the Bowtie Nebula, Caldwell 2. This one's up here, kind of near the, near the peak of the house of Cepheus, if you like. It's a small planetary nebula. You zoom in a little bit here. You can see it. Turn off the symbol. There we go. It's a star-like in a small telescope, but it's better in, say, 6-inch telescope. Aperture telescopes are bigger. Discovered by William Herschel on November 25th of 1787, class 4, number 58. And I've got it as 48% or 44% of the way from Calf. All right. So there's Calf in the W of Cassiopeia towards Polaris. So it's kind of on that line, right between them. but not quite halfway. So 44% of the way. So that kind of makes it a good starting point for aiming your finder scope. I actually star hopped from, there's a couple of stars in the area, 21 and 23 casts. But I think I didn't know that trick about the line between them. So I would use that as your starting point. Once you find it, you want to use relatively high power. So again, at the 35x is not much to show, but let's crank this up a little bit. Let's go all the way up to 150. Now you can see the extent of it, the size of the envelope. So note its shape, its orientation, any field stars around. As you can see here, there are some neat field stars around it, and any variation in the structure of the nebula itself. This one's about 4,000 light years away. And that's it. We're done. We did it. 110. Thanks to Alan Dyer for putting that list together.
Hard to believe it's the end of it. Good. Thank you, Chris, for going through them all and showing us how to find them. I assume, I missed a lot of this stuff, but I assume that you've told people that there's an observing certificate tied to this, right?
Well, we did way back when we started, but yes. So RASC will award you a certificate for successfully observing, finding, observing, and logging all the objects in the list. I don't remember what page in the handbook it is, but it's in the observer's handbook. And yeah, some of the objects are brighter than Messier objects, so there are a few that are harder, but a lot of them are fairly easy to see, and it's worth looking at for sure.
Awesome. All righty, and with that I think is the end of our show.
Wrap for
That's
now.
a wrap.
Yeah, so thanks for all the loyal viewers and everyone that's been with us on this journey from the beginning. It's been fantastic to build that community, and we'll be around, we'll do some other things, but I just don't have the ability to do it on the schedule we were under.
Thank you, everybody, for all of your kind messages and support in the chat. I've been reading through them, and I agree. There's a couple of people just kind of going, sad to see you go. We agree. It was really nice to meet all of you. And I've mentioned in the chat, if ever we do something, some sort of reunion or anything like that, or we start at the new show, I will email everybody who's come to the show just to let you know, in case you'd like to keep participating. And maybe, Chris, we can do one of those virtual observing nights or something like that sometime. I'm sure. To do.
Yeah. Fantastic.
Thanks, everybody. Wouldn't have been the same show without all of you here. So it was really wonderful to feel like we weren't speaking into the void, and to see you responding in the chat was really, really meaningful to us. So
oh yeah, much better to have questions and discussions and tangents. It was great.
Yeah.
All good.
Thank you, Chris, for all your time that you spent on this show.
Happy to have done it. Yeah.
It was awesome.
Perfect. Thank you, Jenna. Thanks, Samantha. Thanks, Charles, wherever you are.
Charles,
yeah.
It was a great show, and we'll see you all next time. Thanks for staying with us for the past 3 years. It's been great.
Yeah, and keep looking up.
Keep looking up. Clear skies, everybody.
Bye now.
Bye.